Okay, so let's see. I'm going to do this one in purple. I need to graph both parabolas, and I'm thinking about factoring because I think that's probably the easiest way. Um, I'm looking at the 3 and the -5, thinking 15, -15. Factors of -15 that add up to 3. And I think, that's a problem. They don't. So I think we're looking at the quadratic formula here. What other choice do I have? So that's what we're going to do. We're going to say x is equal to -b plus or minus the square root of b squared, which is 9, minus 4 times a, which is 3, c, which is -5, all over 2 times 3, 2 times a. Okay, so let's see, what is this? -3 plus or minus the square root of, we've got positive here, 12 times 5 is 60, so we have the square root of 69, over 6. Okay, so we're graphing, so, this is pretty close to 64, so, it's a little bit more than 8, huh? So let's say x is about equal to -3 plus or minus about 8. Maybe we should say 8.2 just to make it seem better. When we add that, we get 5.2 over 6. When we subtract it, we get -11.2 over 6. And that's really close to 1, and that's really close to -2. So I know that's a lot of estimation, but that's... Look where I have to estimate the 1. It's between the lines anyway. Here's 2, 4, 6, 8, 10, so that's about 1. And -2 is about right there. Okay, so right in between those two numbers is, well, we could add them together. We say divided by 2. That's -1/2, right? So I'm going to have to estimate where is -1/2. There's -1. So I'm going to say that's -1/2 right there. So are we estimating a lot? Sure we are. Is it a terrible thing? No, it's not. So now there's one more thing I need to do. I need to find out where on this dotted line is my vertex. So I do that by plugging in my -1/2. This is -1/2 I got over here. And so let's see. We'll say the vertex is going to be when I have... I'm plugging in -1/2, and I squared it. So let me just plug that in. I'll show you what I'm doing here. 1/2 squared plus 3 times -1/2, and then -5. Okay, so that's going to be 3 over 4, positive. Then that's going to be -3 over 2. And then I'm going to say -5 over 1. And I'm getting common denominators. So let's see. Common denominators, I need a times 2 times 2. And I need times 4 times 4. And that's going to give me 3 minus 6 minus 20 over 4. And let's see. We're going to get -26 minus 23. -23 over 4. That's really close to 6. So I'm going to say, here's my -6 down here. And I'm going to put my vertex right there at -6. So this calls for a dotted. You see this? It says y is greater than. Okay. So I'm going to draw this with a dotted line. I guess I'll use... I said I was going to use purple. Let me use purple. Okay, so dotted line, dotted line, dotted line. And we'll just keep this going the best that we can. Oh, I guess it's going through -5. Does that look like it went through -5? I'd say it does. Because right there is -5, right? Right there is -5. Okay, so it looks like it went through -5, so that worked out pretty well. And we're doing dotted lines because it's just greater than, but it's not equal to. Okay, and later we'll shade that, but not yet. Okay, so now we're thinking about the other one. We're kind of hoping maybe that one would be easy to factor. Would it be easy to factor? No, that would be asking for too much, I guess. We have this 10 and we have this -1, and I can't get factors of 10 that are going to add up to 5, so I'll abandon that hope right there. I suppose I could complete the square, huh? How about that? So this one's going to be green on my graph. And so let's think about this. I don't want that negative out in front, so I'm going to say, I'm going to put the negative out in front like this and say x squared minus 5x minus 10. You know, come to think of it, let's leave the minus 10 out. And we'd rather have something else. When we complete the square, what do we do with that middle number? Well, we divide it by 2 and we square it, right? So the perfect number we would like to have is 25 over 4. So we'll say 25 over 4. And then on the outside we still have our plus 10. We didn't do anything with the plus 10. We didn't even factor out a negative from it. We just left it alone. But what we did was we subtracted. I know it looks like we added. You say, well, we added. And I say, well, no, we actually subtracted because there's a negative out in front. So I'm going to go over here and I'm going to add 25 over 4 to undo what I've done. Okay? So I say, okay, so now I can write this as a perfect square. I can say x minus 5 over 2. You remember 5 over 2, right? There, it was over there, 5 over 2. Yeah, and so we'll say that, and we'll say we're going to have this equal to 0. We're going to say plus, I'm going to get common denominators. 40 over 4 is 10, plus 25 over 4 equals 0. And we'll say x minus 5 over 2. And I'll subtract. If I put those together, that's 65 over 4, right? So I subtract it from both sides. I subtract the 65. Maybe I shouldn't do that all at once. But you see that I added these together and I moved them to the other side, so now they're negative. Okay? All right. And let's see. I think I will multiply both sides by -1. Oh, I forgot to say squared. Sorry, squared. Bad, bad, bad. I forgot to say that. We'll say x minus 5 over 2 squared is equal to positive 65 over 4, because I took that negative and I got rid of it on both sides. Now we'll take the square root of both sides, and we're going to do a little fudging like we did before. We're going to say x minus 5 over 2. We get the radicand that comes out of the square root. And you know what the square root of 64 is? It's 8. So I'm going to say 8 over 2. And I'm going to say plus or minus 8 over 2. So that's going to be x minus 5 over 2 is equal to plus or minus 4. And then I'm going to add 5 over 2 to both sides. And as usual, I write the 5 over 2 first. 5 over 2 plus or minus 4. Alright, so this gives me two answers. This gives me 2.5 plus 4 is 6.5, right? And 2.5 minus 4 is minus 1.5. Okay, so those are my two x intercepts, 6.5 and -1.5. So 6.5, well, here's 6, here's 7, so I'm going to say that's 6.5 right there. And my other one is -1.5, so there's about -1.5 right there, between the -1 and the -2. And if I add those together, I get 6.5 minus 1.5. I know I said I'm adding, but one of them's negative, so that's going to get me down to 5, so 5.5, and it's positive 5.5, so that's the same thing as 2.5, right? So this one, if that's 3, then this is 2.5. Oh, wait, I didn't get my... Hang on. Did that wrong. 2.5. So 2.5. Where's 2.5? Well, if that's 3, then, and that's 2, I guess we're right in between. So right there's 2.5. Does that look like it's right between the dots to you, the green dots? Here's this axis of symmetry. Okay. And I should label that as axis of symmetry. I was going to call it the vertex there for a minute. Not good. This is also the axis of symmetry over here. I probably should have made that more clear. And now we want to know, vertex. What's my vertex? Well, let's go back and look at the formula. The formula says I'm going to subtract x squared. So I'm going to say minus 2.5 squared. And I'm going to say plus 5x. So plus 5 times 2.5. And then I'm going to say plus 10. And that's going to give me my vertex, right? My vertex is going to be equal to that. The y value. I could say y. I should say y is equal to that. But anyway, it's the vertex. So 25 times 25 is 625, right? So 6.25. And there's a negative sign waiting on it. If you look back up here at the formula, it's x squared, and then there's a negative sign out in front. If we'd have said negative x squared, then I would have got a positive, but there's no parentheses, so it's going to be a negative. Negative 6.25 plus 5 times, that's 12.5, right? Plus 10. Okay, so let's see. What are we going to get here? We're going to get 6 plus 10 is 16. So I'm going up here to 16. That's my, let's see, 2, 4, 6. There's 16 right there. Okay, and this is negative, and we're not surprised to see that it's opening down. Uh-oh, I was making a solid line. Go back. Better be a dotted line. Okay. And I guess I should have thought about what is this thing when it hits the y-axis? It's 10, right? Because x is 0 and x is 0, so it hits the y-axis at 10, so I should plot that point. There's a point right there. So let me complete this parabola. It's going through the x-intercept over here. Okay, and let me do the first one. That's above, that's greater than the vertex. So here's the vertex, and I'm right above it. And then I'm going to fill in all the area above, which means the inside of the purple parabola. The inside of the purple here. And so I'm shading in the inside. And I know these are long, but we wanted to review these so that you think about them a little bit more. And here's this one is opening, we're going to be less than, y is less than, so I go to the vertex and I'm going underneath the vertex because less than. And that means I'm inside underneath. So now I'm shading all the inside of this parabola. And it's one thing my tablet seems to do very slowly. Very slowly. And I'm shading this in. And you can see that the solution to the system of inequalities is turning green. All the stuff where they share territory is green, and that's the answer. All the dots, the infinite number of dots inside the green field, that is the solution. Not just one answer, but all the points inside all the green field is the answer. Okay.